Good morning, good afternoon, everyone, or good evening. It's a pleasure to be here for this short talk. My name is Davide Pellegatta, and I'm a solution engineer for Couchbase. And today I'm going to talk to you about why we are thinking about the caching, why we use caching in our application, why you should use it with Strapi. If you need it, and why it's really important to avoid some problems. Side chat is going to be also a bit of overview of how you can implement your own plugin for caching if you really want. Like I said, we have a few topics to discuss today, so we will go pretty fast. Hopefully you will enjoy this ride. And at the end of the talk, since I work for Couchbase, I will talk a little bit about why I use Couchbase for this plugin and why it should or it might be interesting for you. And then some resources, of course, in case you want to contribute to one of the libraries we will see today, or just you want to curious around and know more about who we are and what we do. So why we need to think about caching? Well, I think pretty much everyone start to feel a sort of feeling that the spaces between frustration and rage just by seeing this screen, isn't it? The reason why we feel that is because we associate a slow application behavior to a waste of our time. It's basically that, isn't it? And what's behind this? It's generally something that it can start with application that have queries that are designed not well enough to more serious problems. But if we look at this from the perspective of the users, so the people or the machines that are consuming your APIs, the ones that, for example, you are exposing with Strapi, you can think of them as people that are going to be pretty frustrated. They will not be able to focus on what they are doing. They will not be able to navigate your website. And if your website is selling something, this is pretty important and relevant. And if that is, there is a very high chance that you will lose revenues or your job will lose potential revenues. If you see that from the point of view instead of APIs, so the consumer is not a human, but it is a machine, well, the topic is a bit different, but surely won't lose the focus on your website. But definitely you will have a problem. Debugging this kind of problems, you know, it's a pretty complicated, especially if this is placed in microservices, ecosystems, and so on. When this is happening, that you expect the bad behavior, well, the answer is pretty straightforward. When you don't expect it. When you don't expect it, this is not because there is some karma at play. It is not because there is Murphy's law that is constantly playing against us. This is happening when you don't expect it because generally cumulative effects of multiple users using an application can lead to have slow behavior. It's as simple as this. And every single user that you add can amplify the problem. And if the problem is not very big, you will not find out immediately until you have a big peak of traffic. Otherwise, you will find pretty soon. So all of this for saying that is very likely to happen when you are probably on holidays or during your weekend, during the evening, and so on. So we need to find a way to avoid it. And to avoid this, well, we use caching systems. Caching systems that are, on our case, based on a Strapi plugin REST cache. This beautiful plugin, maintained by the Strapi community, is based on a very good and all simple concept. So if you think about the caching in general, is generally based on a key value approach. So you can implement a very simple cache providers using just a memory, just a map, where you have keys and values, where the keys and value correspond to API calls and their payloads, or more abstract form to request and response. And the way they work is simple, and that's why I think it's a very elegant approach. It's simple, but not as simple. We will see why. If you look at this, for example, this is an extract from my log running this plugin with the standard blog example of Strapi. Well, the first time that you are running the example and you are hitting a certain API, what you can expect is that you are going to have a miss. A miss means in the caching world that the value is not stored yet somewhere. And the hit that is coming afterwards means that the value is stored somewhere and so is cached. And so it's provided out of a data structure that is not the disk or the database, but is probably memory. So the answer is blazing fast. And you can see here in this example, it's pretty visible, the difference in the latency. It goes from 29 milliseconds down to 6 or 5 milliseconds. It can be even more if you optimize. And the workflow is pretty simple. There is a request. The cache provider, the cache plugin is checking if this request is already cached. If not, it's a miss and is going to save it within the cache. If it's instead the cache is a hit and is providing the value out of the cache. Simple as this. Where is the tricky part? The tricky part is that the cache need to be aligned. And I think the best way to see that is through a quick demo. Okay, now you should be able to see two terminals. In these terminals, we have one of the playgrounds that is provided through the cache plugin. So this is something that you are going to have. If you check on the packages of a Strapi plugin REST cache, you will see that there is a folder for playgrounds, including the one for Couchbase that I created for this talk. We are going to run the plugin with the debug mode so that we can read what's going on. And the database is already installed. The database is installed here, Couchbase database. Let me see if I can find it here. And in this database, we will use a bucket, which is a database that contains now 0 items. These are items because we didn't initialize the cache and there's nothing yet. So let's start the plugin and let's comment together the first lines we are going to see appearing here. Hopefully there is not going to be any update, so it should be pretty fast. In the meantime, I'm going to run also a front end. The playground is using the usual cache, the usual blog example, so you can see then we are just using a prepared front end for it, just so that we have a consumer. But let's get back to our backend implemented with Strapi and where the cache plugin is already installed. The thing that you can see on startup is that the plugin will register itself with some parameters that are specifying a lot of different things for which you can find a lot of documentation online. So I will not go through that. But the most important part of it is that you are going to choose which part of your backend you want to cache. So on page, category, and so on. We see also that the provider for the cache is started up, and now we will see the part that is more interesting here. So we saw that we have several resources observed by our cache plugin. And interestingly, here we can see that for each method, we have receive, purge, receive. So that means that when we have a method that doesn't implement a modification of this resource, we are going to serve this out of cache. While when we are going to modify this resource, well, we are going to purge the cache. We do that because we want to keep the cache aligned with the content of the database. That means that if you have more than one instance of your Strapi backend plugin, you better have a distributed cache like the one we are going to use today, so that you always are seeing the same view of your data. If we go and check our blog, lost. So we start to receive the first request. Well, the UI is nothing special. You know it already, and we can see that we start to hit the first misses here. Receive, miss. And all these requests, they take a certain amount of time. Then there are other resources like the images that are not cached in this case, and so they are served out of disk the way they are. So hopefully slow in my case. Now I click on a certain page. It does what it has to do. We see some more misses because it's the first time we are hitting this page. And now we want to go back to the home page. Probably you notice something. You notice that this time serving this page was a lot faster. A lot faster in some cases because images were already cached, but also by the browser this time, not by the plugin, but also because all the API have been served out of cache. So you can see hit. You can see that the difference, if we go and look up for articles populate, probably is over there somewhere. Oh, here, categories, populate, API, and so on. We are seeing that we have a huge difference in performances, that they go from some hundreds milliseconds to few tens of milliseconds. And this is an example that you can see deployed on my laptop. You can imagine what it can do in case you are hosting this on a proper server. This concludes our very little demo and bring us back to the structure of the libraries that made this possible. So if we look at this, we see that there is a stack of different libraries at place. Well, there is Strapi, that is our backend. There is the plugin REST Cache that is providing a high level or an infrastructure for making caching possible. There are then providers for this plugin. And then there is an underlying cache manager that is just a simple caching, the way you can imagine, that is very, very generic and not Strapi oriented. So it doesn't go and cache Strapi resources, and it's not meant to be working that way. We need something in the middle, our plugin. Each one of them has a modular approach so that you can create providers. And that's what I did, basically. I created first a plugin for a provider for the cache manager, a very high level implementation that provides method like a get, set, and so on. The cache manager then provides the implementation for going around methods or just to use it as is. So just with the methods that we saw. On this part, the plugin REST Cache is going then to provide the infrastructure, like we said, and providers. In this case, providers are pretty important because they allow you to create a binding between Cache Manager and Strapi itself. And if you have a complex implementation when you need to recycle instances of the cache manager because you are using it in a multiple points of Strapi and so on, that's why you have these providers in place. So hope this gives you a little bit of an idea. We can just explore very quickly from the point of view of code what it means, just to corroborate my thesis that is simple and elegant. If you look, for example, at the cache manager implementation of the provider, you can see that there are a few methods that are used by the cache manager to make this possible. Set, so set something. Get, when you want to get something, given a certain key, you get a value, you can specify a callback or whatever. Delete if you want to remove something. Reset if you want to empty the cache, and keys if you want to list all the keys. By the way, I forgot to show you before, in the database, that's what you can expect to find, a little bit like the screenshot before. So if you run a get, you will get against this key, that is exactly the API you are calling, and you will get back the payload that it is supposed to serve. And this is already pre-calculated, so your application will go very fast. If you look then at the Strapi implementation of the provider, it's pretty much simple, similar to the other way. In this case, because for Couchbase, the implementation is very simple. So get, we get the cache provider get. We don't use the cache provider for Couchbase, but the cache manager provider, so the abstraction, so that you can change in case whatever you want, and so on. It's very, very straightforward. And then from this, there is a base for complicating, if you like. But that to say that it's pretty easy if you want to integrate your own plugin, create your own, or if you want to help us out contributing, well, it's more than welcome, of course. Let's have a look then to finish this conversation at Couchbase, why I'm using Couchbase and why I think Couchbase is relevant in the context of caching. Well, Couchbase is a database that is memory first. So it's providing, when there is enough memory, all the content out of RAM. And if it's not enough RAM, well, it will choose the most used items and provide just them out of cache and the rest out of disk. It's very simple to use because as a structure that provides replication and disk management completely transparently, so you don't need to think about caching, about sharding, about deployment options, and so on. It's very, very straightforward. It has a very elegant structure from the point of the architecture. It does have a no master slave architecture. It has automatic sharding, so all the data will be spread automatically, and that goes for active and replica because it has a share nothing architecture. And when you are adding node, you are basically redistributing the data across all the available. It has also automatic failover in case something gets wrong. So that if something gets wrong with one of your server, that goes from the guys unplugging it to some hardware failure. Why not? It happens sometimes. Well, the Couchbase cluster instance will take care of excluding the nodes that are unhealthy. And it doesn't have any single point of failure by design. So the only actors involved in the conversation are your application with the Couchbase library embedded. In our case, it's in the cache manager provider, and the database itself, as simple as this. Well, with this, I think we are concluding this talk. At this address, you can find all the material that we use today, materials, and so that you can wander around, have a look at the libraries, maybe try Couchbase. Why not? There is a beautiful playground that I advise you to try to use. And why not? We're trying it with your Strapi instance. So in saying so, I would like to thank you for checking this out, to spending these 20 minutes with me. And if you want to contact me, you can find my reference here or on the page I mentioned before. Thank you very much, and I hope to see you in presence once, hopefully. Bye-bye.